Hey everybody, Mr. Bucko back here on Hat Day with a couple of examples of convex and non-convex sets in case you want to take a look at a couple more. So we'll talk about those right now. We have a figure on the screen here that is colored in, denoting that everything within this figure here is a part of the set, and we're going to determine whether or not it is convex or non-convex. And this would be a non-convex figure because if I take 2 points and plot point there, and let's plot another point here. If I connect those 2 points with a segment, a line segment, go from this point to this point, notice that this segment here goes out of the figure. It's not in the set. This part of the line segment is not in the set that is colored in. So therefore, this set, this yellow set here, is non-convex because when we connect these 2 points, the line goes outside of the figure. Sure, we can take 2 points within the figure and connect these two, and that segment stays inside the set. So you'd say, well, wouldn't that be convex? No, because we have 2 points here that go out of the set when they are connected. It has to work for every 2 points, any 2 points within the figure. So this would be, let's type it out, non-convex, and it is non-convex because of this segment right here. Let's do another one. This figure here would be convex because if we take any 2 points, put a point here, put a point here, if we connect those 2 points with a segment, that's within the set. We pick 2 more points, let's say this one and this one, though that would also be within the set as well. So we can pick any 2 points. I mean, I can go on and plot points all over the place. And no matter what, no matter which 2 points I pick to connect, the segment that connects these 2 points will be within the shaded area there. So this would be a convex set because any of those points that are on the screen that are in the figure here, they will all be within the segment. If I was to connect those two, the segment would be within the set. So this would be convex also. And you can just do this all day long. I'm not going to, but I could, but I'm not. Moving on, this one here. Notice this figure here is not shaded in, so that means that the stuff within the circle is not within the set. So the only points that are within the set are anything that's on the circle. So this is in the set, this is in the set, this is in the set, this one, so on and so forth, but I have to be on the circle because the interior is not shaded in. Well, if I connect this point to this point, well, this segment is going outside of the set to get across to that other circle. It has to be a line segment, it has to be a straight line. So with that, this would be non-convex. That would be a non-convex set. Make that a little bit bigger so you can see it. Oh, well, maybe that didn't help. There we go. That's a non-convex set because that segment goes outside. This one's a little different. Notice that now, I don't know if you can see that or not, but the interior is shaded in. So now this is a point in the set, this is in the set, this is on the set, anything on the circle. And notice I can plot all these points. I can pick any 2 points I want to, put them all over the place. And if I connect any of these points within the set, I will always, the segment will always be within the set. So therefore, this would be a convex set because we are always within the set no matter what. Couple more. This one here, you could say, well, I'll plot a point here and here, connect those two, must be convex. Plot a point here and here, connect those two, that must be convex. Well, what if I connect this point to this point? Now we have an instance of the line segment connecting these 2 points going out of the set. Therefore, what does that mean? Yep, non-convex. Be a non-convex set. Almost done here. I know this one's going a little bit longer. Line here, there's a line that goes on forever in both directions. So anything on that line, any point on that line is within the set. All these things are in the set. Anything off the line here, not in the set. So this would be convex, because if I connect these 2 points, whoops, that shouldn't have happened, but it did. Ignore the dotted lines, please. But if I connect these two, I'm still on that line, even though that's dotted. If I connect any of these points, I'm still within the line, so therefore this would also be a convex set. And a couple more. This one, non-convex. Put a point here, put a point here, connect those two, outside. It goes outside the set, outside that shaded area, so that's non-convex. I'll save us some time and not even write that one down. This one here, imagine that there's this teal area, I guess if you call it that, is the set, and this green within here, this is not a part of the set. This would also be non-convex, because if I pick this point here and this point here and connect these two with a line segment, this line segment goes outside of that teal area. So this would also be non-convex too. So those are a couple more instances and examples of convex and non-convex sets. I apologize for such the long explanation here, but in case you want to go back and look at a couple of those, there they are.